We will now be looking at Investigation 2.4.4, problem number 5 on page 120. In this particular problem, you are going to be looking at the typical handspan of the students in our class. I went ahead and made a sample data set for a group of 4 students. In this particular data set, 20 and 1/10 centimeters was the largest handspan, and 15 and 4/10 was the smallest handspan. But the other 2 students had a handspan of 18 and 3/10 and 16 and 2/10 centimeters. The first part of the problem asks you to find the mean of the handspans. I went ahead and calculated the mean for my set of data. Recall that in order to calculate a mean, you want to add up the data set and then divide by the number of items in the set. Here I have 4 students, so I divided by 4, giving me an average handspan of 17.5 centimeters. Next, you were asked to calculate the deviation from the mean. If you recall, the deviation from the mean is simply the data values minus the mean, which in my particular case gave me these 4 values. If you recall from the last problem, when we take a sum of those deviations, we should end up with a value of 0. In this problem, you are asked to do that. I went ahead and added my 4 deviations together, and I did end up with a value of 0. We're going to skip part B of this problem and move on to part C. So at this point, I would like you to go ahead and measure the handspans of the students at your table, and then calculate the deviations from the mean. You can stop the recording at this time while you complete this part of the investigation. You are now ready to calculate the standard deviation. The steps for calculating the standard deviation are outlined in Part C. I have gone ahead and calculated the standard deviation for my sample set of data. The first part, you're simply going to use the 4 data values that you calculated above, the deviation from the mean. In order to calculate the standard deviation, the first step is to square each of those numbers. Of course, you're going to end up with positive products because when we square any number, it's going to end up being positive because, as you know, a negative times a negative is also a positive product, just like a positive times a positive. So these are my 4 values I get when I square my deviations. The next step then is to add up those values, and I arrive at a value of 13.5. Next, I need to divide by n minus 1, which is simply the number of items in your data set minus 1, which gives me a value of 3. And when I take 13.5 divided by 3, I get 4.5. The final step for finding the standard deviation is to take the square root of that number. In problem number 7, we'll discuss what squaring the deviations does and what taking the square root allows you to find. At this point, go ahead and calculate your standard deviation for your set of data. You can stop the recording until the groups are completed. We are going to skip Part D and move on to E. E gives you a sample statement. I have also made one for my set of data. The handspan of our group averaged about 17.5 centimeters, with a handspan typically being about 12.5 centimeters from the average. And if I go back and I look at my set of data, that value should make sense because most of my data, these 3 points here, end up being within 2.5 centimeters from my mean of 17.5 centimeters. The only one that doesn't is the 20 and 1/10 centimeters, which seems to be a fairly large handspan compared to the others. So if I were to make a histogram of this data or a standard deviation graph, it would fall within the bottom 17% of the data, whereas the rest would be in the middle 2/3. At this point, you could go ahead and write a summary statement for your group, and then you can move on to problem number 6.